You walked up to your truck this morning the same way you do every weekend, coffee in hand, ready to spend some time with something you actually care about, and then you saw it. Right there on the front bumper, spreading like a disease across the mirror-bright chrome you spent 3 Saturdays buffing to perfection, a cluster of brown rust spots eating into the metal like acid. And not just a little surface discoloration you could wipe away with your thumb. We are talking deep, crusty, orange-brown corrosion blooming out from the edges of your exhaust tips, creeping along the trim rings, turning what used to look like liquid silver into something that belongs on a junkyard carcass left out in a field for 30 years. That feeling in your gut right there, that sick drop when you realize the chrome you love is being destroyed in real time, that is exactly what the detailing industry has been counting on your entire life. So you did what they trained you to do. You went to the auto parts store, you grabbed a $30 bottle of whatever paste had the shiniest label and the most aggressive marketing copy, you came home, you put on your worst t-shirt, and you started scrubbing. An hour went by, your forearm was burning, the rag was turning colors. You were inhaling fumes that made your eyes water and your throat close up a little, and when you finally stepped back to look at your work, the rust was still there, maybe slightly lighter, maybe just smeared around into a new pattern. But it was still there, and now your chrome looked somehow flatter than it did before you started, like the reflection was just a little bit hazier, a little bit more muted, a little bit less like a mirror, and a little bit more like brushed steel. And you told yourself it was fine. You told yourself it just needed another application. You told yourself the product needed time to work. But deep down, you knew something was wrong, and you were right, because you had just been robbed in your own driveway, and the company that sold you that bottle knew exactly what they were selling you before you ever opened it. What I am about to show you costs 5 cents. You already own it. It is sitting in your kitchen drawer right now, folded up next to the plastic wrap, and it is going to remove those rust spots in 10 seconds flat using nothing but basic chemistry and a splash of water from your garden hose. No scrubbing, no toxic fumes, no burning forearm, no hazmat cleanup. I am talking about a crumpled ball of standard household aluminum foil dipped in plain water. And before you click away thinking this is some internet myth or some stupid life hack that sounds good in a thumbnail but fails completely in real life, I need you to stay with me for 60 seconds because the science behind why this works is going to fundamentally change the way you think about rust removal forever. Aluminum foil reacts with iron oxide at a molecular level when water is introduced as an electrolyte. That is not a metaphor. That is not marketing language. That is a documented electrochemical process called a galvanic reaction, and it is the same class of chemistry that protects naval ships from corrosion and keeps underground pipelines from rusting through. You are not scrubbing the rust off. You are chemically converting it and causing it to release its grip on the chrome at the atomic level, turning hard, crusty corrosion into a soft, dark paste that wipes away with zero effort. That is not a $30 bottle of polish doing that. That is a piece of foil that costs less than the tax on that bottle. Now, before we go any further, I need you to hit that subscribe button right now, because what I am about to explain about the detailing industry is something they have spent millions of dollars in advertising to make sure you never figure out. These companies are not selling you a solution. They are selling you a cycle. They know exactly what is inside those shiny bottles of chrome polish and metal compound. They know it better than you ever will because they formulated it. And what they put inside is suspended abrasive grit. Not gentle, not safe, abrasive. The same fundamental mechanism as sandpaper, just suspended in a thick carrier paste to make it feel luxurious when you spread it on your finger and rub it into your palm in the store aisle. Every single time you open that bottle and go to work on your chrome trim, you are dragging microscopic particles of cutting compound across the surface of your plating. And the detailing corporations are counting on the fact that you will subscribe to them every season like clockwork, walking back in with your worn-out forearm and your hazy chrome and your credit card already out. Hit subscribe. Join the people who have stopped playing that game. We are building something here, a community that does not hand money to companies that profit from your ignorance. And every video on this channel is another brick out of the wall they built around your wallet. Now let me give you the actual physics of why aluminum foil cannot scratch chrome, because this is the part that makes people genuinely stop and stare when they hear it for the first time. Every solid material has a hardness rating on what materials scientists call the Mohs scale. Diamond sits at the top at a 10, talc sits at the bottom at a 1. Chrome plating comes in somewhere around 8.5 to 9, which is why it resists scratching so well under normal conditions and why it holds that mirror finish when it is clean and protected. Standard aluminum foil rates out at roughly 2 to 2.5 on that same scale. That means aluminum is so much softer than chrome that when the two surfaces make contact, the aluminum is the one that deforms, not the chrome. The foil conforms to the surface, it sacrifices itself. It cannot cut into chrome any more than a wet napkin can scratch a piece of glass. That physical impossibility is the foundation of why this works safely. But the magic is not in the rubbing. The magic is in what happens chemically the instant water bridges the gap between the aluminum and the rust. Rust is iron oxide, which means it is iron atoms that have bonded with oxygen atoms through a process of oxidation. That bond is what gives rust its hard, flaky, crusty texture and its characteristic brown-orange color. It is not just discoloration. It is a new compound entirely, a chemical product of iron giving up electrons to oxygen. Aluminum is what chemists call a highly electropositive metal, which means it has an intense natural drive to give up electrons, far more intensely than iron does. When you introduce water as a conductive medium between the aluminum foil and the iron oxide sitting on your chrome, you complete an electrochemical circuit. The aluminum begins donating electrons aggressively, and those electrons travel through the water bridge directly into the iron oxide compound. This forces the iron oxide to release the oxygen it has been holding onto. The oxygen migrates toward the aluminum instead, which is why you see a dark gray or black paste forming under the foil as you work. That paste is not ground up chrome. That paste is not abrasive residue. That black material is the rust in its reduced form, the loose mineral byproduct left behind after the galvanic reaction has broken the iron-oxygen bond and liberated the iron from its corroded state. You are not mechanically removing rust. You are chemically dismantling it, molecule by molecule, and watching it surrender. That is a fundamentally different operation than what happens inside a bottle of chrome polish, and the difference is not subtle. Let me tear open one of those premium chrome compound bottles right now and show you exactly what you have been paying $30 for, because once you understand the formulation, you will never be able to look at that product without seeing what it actually is. Chrome polishing compounds and metal polishes of all varieties rely on one core active ingredient for their rust-removing and shine-restoring properties: abrasive particles suspended in a liquid or paste carrier. The specific abrasives vary by brand and by price point. Cheaper products use aluminum oxide or silicon carbide particles. Higher-end products market themselves with refined alumina or cerium oxide, giving these compounds names that sound like precision engineering but are functionally just describing different types of grit. The carrier fluid, often petroleum distillates or silicone compounds, gives the product its texture and makes it spread smoothly across the metal surface, creating the sensation of a luxurious, high-performance product even though the actual working mechanism is identical to what happens when you drag sandpaper across wood. The abrasive particles cut. That is their function. They are designed to mechanically remove material from the surface you are polishing, which is exactly how they eliminate rust, by grinding down the corroded layer along with a thin slice of everything underneath it. On chrome plating specifically, this is a slow-motion catastrophe. Chrome plating is not a thick layer of solid metal. It is a deposited film, typically somewhere between 10 and 30 microns thick, applied through an electroplating process onto a base metal substrate. Every time you polish that surface with an abrasive compound, you are removing a portion of that film. You cannot see it happening in a single session. After 5 sessions, after 10 sessions, after a full season of monthly polishing the way the label instructs you to, the chrome layer is measurably thinner. The surface that was once a crystalline, molecularly smooth mirror finish now has a topography of microscopic scratches that scatter light in all directions instead of reflecting it cleanly back at you. This is why your chrome looks slightly hazier every year, even though you have been polishing it regularly. You are not maintaining the finish. You are consuming it. And here is the part that makes the whole scheme so diabolically effective. Those microscopic scratches are not just cosmetic damage. Each scratch is a microscopic channel, a tiny valley in the surface of the plating that collects moisture, holds road salt, traps mineral deposits from rain and car washes, and provides the exact sheltered, low oxygen environment that iron oxide needs to establish itself and begin growing. The polishing compound does not solve your rust problem. It accelerates your rust problem while simultaneously degrading the chrome that was protecting the base metal underneath. This is not a design flaw. This is not an oversight. This is a product ecosystem engineered to require your continued participation, and the $30 bottle of compound is the enrollment fee. Now let me give you the exact protocol for using the aluminum foil method because execution matters, and there is one critical safety point you absolutely must understand before you touch foil to chrome, or you will cause damage that no polish on earth can fix. Start by giving the rusted area a thorough rinse with plain water from a hose or a spray bottle. You want the surface wet and free of any loose dirt or grit before you start. Loose abrasive particles sitting on the chrome surface during any rubbing action are the most common cause of accidental scratching, so flush the area completely and do not skip this step. Tear off a piece of aluminum foil roughly 6 to 8 inches square. Standard kitchen foil is correct. Heavy-duty foil is too thick and too stiff. Do not use steel wool, do not use copper scrubbers, do not substitute any other metallic material. The specific hardness and electrochemical properties of aluminum are what make this reaction safe and effective. Crumple the foil loosely into a ball or a pad shape. You want some texture and surface irregularity so it makes good contact with the contours of the chrome, but you do not want it compressed so tightly that it becomes a hard, rigid object. Dip the foil ball into your water source, or better yet, keep a small bowl of water nearby and re-dip every 10 to 15 seconds throughout the process. Now apply the wet foil to the rust spot and use the absolute minimum pressure required to maintain contact. We are not scrubbing, we are not bearing down, we are not trying to physically dislodge anything. The goal is to keep wet aluminum in continuous contact with the rust so the galvanic reaction can proceed. Light circular motions or back and forth strokes with almost no downward pressure. You will feel the texture of the surface changing within a few seconds. The hard, crusty resistance of the rust will soften. You will begin to see the dark gray or black paste forming, which is your confirmation that the reaction is active and working. The critical warning. Listen to this carefully because getting this wrong causes irreversible damage that cannot be polished out, buffed out, or corrected without professional replating. You absolutely cannot allow the foil to dry out while it is in contact with the chrome. If the water evaporates off the foil and you continue rubbing with dry aluminum against the chrome surface, you have eliminated the electrochemical reaction entirely and replaced it with direct metal-on-metal dry abrasion. Dry aluminum on dry chrome at any pressure creates friction heat. That friction heat causes microscopic rust particles and aluminum particles to become momentarily molten at the point of contact. Those particles, now in a semi-plastic state, are dragged across the chrome surface by the continued rubbing motion, and they cool back into a solid state while embedded in fresh scratches they carve during transit. The result is deep, fine-line gouging across the surface of your chrome that appears as a matte or frosted texture in the previously mirror-bright areas. These are not surface scratches. These are structural damage cuts through the chrome film into the base metal, and no amount of polish or compound will remove them without removing even more chrome in the process. Keep the foil soaking wet. Dip it constantly. Apply more water from a spray bottle if your bowl is not nearby. Let the chemistry do the work and keep your pressure near zero. When the rust is gone and the dark paste is present across the treated area, wipe it away with a clean, damp microfiber cloth. Rinse the chrome thoroughly with fresh water. Allow it to dry, and then finish with a thin coat of wax or chrome sealant to protect the now clean surface from reoxidation. That is the entire protocol. No burning forearms. No toxic fumes drifting into your face for an hour. No hazy finish left behind as evidence of what you had to do to fight the rust. 10 seconds of gentle contact, a wipe, a rinse, and done. Compare that experience to what you went through the last time you grabbed that bottle of polish. Compare the time investment, compare the physical effort, compare the chemical exposure, compare the quality of the result. Compare the condition of the chrome the week after, when the microscopic channels left by the compound gave new rust its fastest possible colonization pathway, while your galvanically treated chrome is still clean and intact. There is no version of this comparison where the $30 bottle wins. There is no scenario where the aggressive abrasive outperforms basic electrochemistry performed with a material you already own and were probably about to throw in the recycling. The only people who benefit from you not knowing this are the corporations selling you the compound, the professional shops charging you by the hour when your chrome eventually becomes too hazed and pitted from polish damage to save at home, and the replating services waiting at the end of that road when the chrome film is finally consumed down to bare metal. Now do me a favor. Right now, before you close this video, think about one person you know who owns a motorcycle, a classic truck, a vintage car, a diesel rig with chrome stacks, anything with chrome trim or exhaust components they care about. Think about how many times you have seen them at their driveway, towel in hand, working a jar of polish into their pipes or their bumpers, chasing a shine that keeps getting further away no matter how much they polish. Send them this video. Share it directly to their phone. Post it on whatever group chat you have with car people. Put it on the forum. Put it in the comments section of whatever detailing channel they follow. Because every week they spend polishing with compound is another week their chrome gets thinner, their scratches get deeper, their rust comes back faster, and the industry gets richer off their loyalty to a product that is systematically destroying the thing they are trying to protect. This took 5 cents and 10 seconds. Pass it on.